stop that habit of listening only when you are shown a method. Learn the concept. What does this mean? Don't tell me how to do it. Tell me what it means. Riley. It means 2x times 2x, yes? Why did you put the 2 and the x in both of these? Because this squared, I have to multiply the whole base, don't I? Right? So in this question, what's the base? X plus 2. So I must multiply it how many times? Twice. Isn't that double distribution? X times x, x squared. X times 2, 2x. X times 2, 2x. 2 times 2 plus 4. There's 4 x's that show up in the middle of that, isn't there? Now that I've just shown you a concept, and most of you stopped listening, now I'm going to show you how it works. That is multiply, isn't it? Yeah. The reason that 2 can go to everything in there is because an exponent just deals with repeated multiplication, doesn't it? What's that? Addition. Do exponents deal with addition? No, exponents deal with multiplication. Therefore, you cannot distribute that the way you have in the past, because this is really squaring the whole thing. Everybody Gouda? Now stop for 1 second. I want to show you one more thing with it. What if I told you that x equaled 4? What would you do with that information with what's highlighted in yellow? 4x plus 2? But x equals 4. So x is 4. What would I write here instead of x? 4 plus 2 squared. Now, according to BEDMAS, what do you do? Brackets. Do you see some brackets? Not yet, because I have a crap computer. Oh, there they are. 6, which is 36, yes? Does everyone agree? Okay. Now, x still equals 4, but what would you do with the blue? What is this first x? 4 squared, yes? What is the second x? 4 times 4 plus 4, yes? What is 4 squared? 16. What is 4 times 4? 16. Plus 4. What's 16 and 16? What's 32 and 4? 36. Does everybody get it? Now, if you did... Yes, you could have. But I'm going somewhere with it. If you do this... Not yet. X squared plus 4, which is what you wanted to do, and x equals 4. Well, we know here 4 plus 2 is 6, and 6 squared is 36, right? So if this were right, this would also equal 36, wouldn't it? Does it? No, what's 4 squared? Plus 4. 20. So another reason it can't be right. Yeah? Yeah. All right. So everybody should be okay with everything now. C, D, E, and F should be no problem. Anybody need to ask about them? I hope not. Excellent. That's fine. That's your business, not mine. Turn the page over. Now that you have done a whole page of binomial expansion, it's time to give you your math present. If you were going to do this the way I taught you, you of course did x squared minus x minus 2x plus 2, yes? And then, of course, you collected your like terms. X squared minus 3x plus 2. Yeah? Now, I'm going to show you something. Look at what I am highlighting in blue. Is there something common between everything that has been highlighted in blue? What is it? They add to 3, don't they? Right? Now, look at what I am highlighting in green. Is there anything that is in common between everything highlighted in blue now and what is highlighted in green? They multiply to that, don't they? Now, what do you notice about everything highlighted in yellow? It's just a single letter, yes? Now, I want you to, don't bother turning back a page, just have a look at what happens. Is that a single letter? Yeah. Is the computer frozen? The answer is always yes. Is the computer still frozen? Yes. Is it still frozen? Yes. Still? Yes. Still? Yes. Still? Yes. Still? Yes. Oh, hey, now we're in business. So, those are single letters, yes? What do you notice about what's green? They add to positive 1, don't they? And what do they do there? Multiply to that. What happened here? What's 9 minus 7? 2. What's 7 times negative 9? Negative 63. So what shortcut do you now have if you start with one letter? Yep. If I start with a single letter, so if I start with a variable, plus or minus any number, and I have that same variable, plus or minus any number, I know my answer is going to be the variable squared, and then this one is going to be plus or minus. What do I do with a and b to get that middle term? A plus b, and then I have the variable, and then plus or minus, what do I do with a and b to get the last one? A times b with no variable. Everybody see that? But it only works when it's a single letter. That's why I didn't show it to you yesterday, or 2 days ago, or 3 days ago, or 4 days ago. Because I wanted to make sure you could actually do the work before you got the shortcut. Okay? Okay. So there's the first one. No shortcut, just distribute. What about this one? Can I do the shortcut? Yes or no? No, why? Because I got a number at the front, don't I? Only works when it's just a letter. But there's the right answer. Now, look at C. Does C have only a letter at the front? Yeah, X and X. So the shortcut maybe could work, right? If there was no Y there, could I do the shortcut? Yeah, 2 minus 2 would be 0, so I'd have nothing in the middle. And negative 2 times positive 2 is negative 4, right? Well, now you just add the y in. Y times y is y squared. Does everybody see? as long as the first term is singular, you can do this trick. Yeah? So, this one, now you know what that means, right? That means that the computer's freezing. That means x minus 4 times x minus 4. Is that a letter at the front? Can I use my little shortcut? X squared, what's negative 4 minus 4? Negative 8. What's negative 4 times negative 4? Positive 16. Sweet, hey? I know you guys think it's cool, you just don't want to say it in front of your friends. Thanks, Mr. Myers. Now we don't have to do FOIL half the time. You're welcome, guys. I hate FOIL. I'm out to get it. Huh? Then use it. And there, of course, is the last two. This one, of course, is what you just learned up here. When it's cubed, it must be x minus 3, x minus 3. And then, of course, I personally always FOIL the second two. Or I use the shortcut. Then I distribute this in there. Everybody good up to page 123? Sweet! There's page 124. Check your work. Make sure you can do it because you're having a quiz on this on Monday, and it's the last time I'm going to specifically talk about it. On polynomial multiplication. This sheet, page 124, could be your quiz on Monday. Yes. No. I'm saying that it will be a sheet of paper that looks like this. Well, if you can do it 5 times, then you can do it every time, right? Yeah. Does anybody need to talk about any of these? Because you'll notice I haven't done the work. I've just shown you the answer because I'm doing it in my head. Everybody okay? Sweet. And there's the last ones. Huh? K is right there. L is right there. M is right there. And N is right there. Jack. Of course you can, Jack. I wouldn't dream of allowing you to become dehydrated. I understand that. Well, golly gee willikers. My son had to do an audition last night for a TV show that will have Jim Carrey and Jason Bateman on it. He won't get the part, but he got to audition for it. But he had to say some bad words. And my son hates to swear. And in the audition, he also had to pretend to take a bong hit. He didn't like that either.
Wait, did he have to swear? Did you get to go Jim Carrey?
No, it was. If I'd met Jim Carrey and Jason Bateman for the audition, I would have had to fly to LA. I was here yesterday. Oh yeah? Nice. It's a TV show that's not been made yet. I'm trying to listen, Riley. Your girlfriend's cousin? Did you say? Your girlfriend is his cousin. Oh, nice. 13. I know, right? Hey, Tasha, we live in Abbotsford. It's not like there aren't 12 and 13-year-olds out in our town hitting the bong hard and cussing at their parents. Please. Right? We go to school every day beside a hole in the ground filled with 12-year-olds hitting the bong hard and swearing at their parents. In the ravine, over in the smoke pit right there, out on the street, down over there, half the time in the halls. Yeah, vaping in the changing room.
Yo, there's so many people vaping.
The only thing lamer than actually smoking is vaping. That's just my thing. If you gotta have apparatus, yes. If you gotta have apparatus, I think that's pretty lame. Especially because all it is water steam. No, I know you can get the ones that have other stuff in them. I'm aware of that. Yeah. Ooh, mine's black raspberry. What's yours? I have vanilla. Oh, really? I have lame. Because when I want vanilla, I go get an ice cream cone. At least that's, you can say to the girl, hey, want to get an ice cream? That's a fun date. Hey, want to go vape in my back seat? Yeah, it doesn't sound like as fun a date. But, again, that is just my opinion, which some of you are going to say, Mr. Myers told me to take up smoking, which is, of course, not at all what I said, but... Huh? I know, that's what you are going to think, or what you actually heard. But that's what you heard, but that is not what was actually said. Yeah, exactly. All right, so we are good with polynomial multiplication? Lovely. Turn the page over, please, onto page 120, blah, 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 blah. All right. Before we go on, I need to remind you guys of something. Over here on the left, I'm going to start talking about factors. Now, factors are really, really important because you have to know what they actually are. And factors are simply any, at least two things that are multiplied together. Okay? So if I were to write 2 times 3 times 6, those are all factors. Now, if I actually multiply them together, of course, I get the number 36. And they are indeed factors of 36. And as soon as my computer thaws, I'm going to talk more. But now, 36 is the product. Now, when you first learned about factors back in grade 3, grade 4, I don't know when it was, Mrs. Bag Crumble said, write the factors to a bunch of numbers, right? And for example, let's say she chose, indeed, 10. So what you guys did was you knew that 1 times 10 and 2 times 5 are the factors of 10. And you knew that any pair of those would make 10. And that's where your factoring knowledge stopped the first time it was introduced to you, right? We all remember seeing something like this. Maybe you did factor trees then too. Then you never touched factors again until we talked about prime factors, yes? And we found out how powerful prime factors would be because they allowed us to simplify radicals, yeah? Prime factors allowed us to find that the square root of 48 is really the square root of 2 to the 4th times 3. And then I took out those prime factors. What is shared in all of these versions of factoring? Everything has to have division happening. Yes? Okay. Now, you guys are smart kids. If everything on the multiply side is a factor and everything on this side is a product, let's come over to this example right here. What would you call those two things? Those are factors, aren't they? Because they are two things being multiplied together, yes? What is one of the factors? 4. What is the second factor? X minus 5, because they are grouped together. Yes? Now, if we were to draw this out, this says in English 4 times x minus 5, doesn't it? So if we were to draw this, and we're not going to draw the blocks, we're going to say, okay, if I need 4 x minus 5s, well, there's 1, there's 2, there's 3, and there's 4, yes? So how many x's do I have there? 4 x's. How many 5s? 5, 10, 15, 20. Everybody cool? So that's what's actually happening, which makes this 4x minus 20 the product. Everybody cool? Now, you guys are smart kids. When we wanted the factors of 10, we took the product and we did division to it, yes? Right? Okay. Now, I'm going to ask you to think back to another thing you learned when you were a kid, and I'm going to write it way over here. If you ever saw this, 4 over 20, would you ever have handed a question in to Mrs. Bad Crumble with that as an answer?
No, you would simplify it.
You would simplify it to what? No. You might go 2 over 10. Right? You would go 2 over 10. And then what would you say to yourself, Josh? And exactly what you just did. Wait a minute. I can go one more, can't I? And you would make it 1/5. Right? Now, what about this made you think I should simplify that? Go. Because they were both even numbers. Okay. What if I gave you this? What about that would make you simplify it? They're both multiples of 3. Excellent. What if I gave you this? 8 and... No, that won't work. I don't want to do that one. What if I gave you... And... that. Because one's odd, one's even. Again, they're both multiples of 3. So all of you, when you see something that has the potential to be simplified, you can recognize it, yes? Okay. Do you see a similarity between that and that? What is it? Those two numbers are simplifiable, aren't they? And how do you simplify? What did you do to 4 and 20 to get 1/5? You did division. So what would you do to 4 and 20 to break it down? Divide, right? And you would see that when I do that division, really ruins my flow. When I do that division, I end up with 4 and x minus 5. Because 4x divided by 4 and 20 divided by 4 gives me those answers. So all of you should see that, yes, we can expand through multiplying, but we can also simplify through division. Does everybody see? Really simple equation, really simple answer, really simple concept that you know from the 4th grade, yes? All right, now let's have a look at this second situation right here, because this is slightly different. How many factors are there? 2. How do you know it's only 2? Because I can plainly see there's 4 things there. Why is it only 2 factors? Not quite, Jashin. Because there's brackets. So this is factor 1, yes? And this is factor 2, yes? And when I multiply them together, can I use my little shortcut here? It would be very helpful if I could. That would be x squared, and what's 4 plus 2? 6x, and what's 4 times 2? 8. So now, you should be aware that there was some mathematical process that allowed me to get from this product back to my factors, yes? So doesn't that mean there must be a mathematical process to get from this product back to these factors? Yes, there is. We're not going to do this one today. We're going to concentrate on this one. Everybody cool? Okay, Riley. Of course you can. It's that time, isn't it? I don't know why that factor 12 is there. It shouldn't be. All right. So, we are not going to worry about... Actually, I'm going to do this once. I'm going to do this, but not with algebra tiles. We're going to do this with a picture. How would you draw 6x?
I draw 6 rectangles.
6 bars. Right?
Yes, sir. More.
And how would you draw 3?
Small dots. Small dots. Small little squares.
Small little squares. Cool. Now, if this is something to be factored, then this must be what? A product or factors? A product, which means I must be splitting this up into its pieces, yes? What are the ways I could divide 6?
By 3.
I could divide it into groups of 3, which I will do in a moment. I'm getting to that too. That's exactly what I needed to hear. I could divide it into groups of 3, couldn't I? But I could also divide it into 2 groups of 3, yes? Everyone agree? Okay. One of those 2 methods will work on his partner. Which one? The blue line or the red line?
Red.
The red lines. Because I have to be able to divide both parts of it by the same number. Just like when I am doing 4 over 20. I got to divide by the same numbers. So, since I know I'm going to divide both of these by 3, as Sam has already said, I can get rid of this blue line, yes? So how many x's are in each group? 2 x's. 2 x's. And how many 1's are in each group?
1.
Plus 1. That is one of my factors, isn't it? And how many of them do I need to get to that product? 3. So these are my factors, and this is my product. Does everybody see? Yeah? Easy peasy lemon squeezy, right? Yeah? Okay. Draw a line. Don't turn the page. Draw a line down the middle. The bottom of your page. Everybody understands how we got it with a picture, yes? Okay. Now I want you to think about this. What Sam said. Sam looked at 6 and 3 and remembered the whole thing we talked about, fractions and everything, yes? And said to himself, 6 and 3 both work with the number 3, right? So what Sam did was he said, all right, I had 6x plus 3, and I know 3 works with both of them. I know I need to divide, so he divided by 3 and divided by 3 to get 2x plus 1. And then he said to himself, I need 3 of them to get my 6x plus 3, right? Right? So what did he do? The first thing he did was he noticed a GCF from way back when we first did these things in the roots unit, yes? Greatest common factor between 6 and 3 is 3, right? Then he divided by that. Then he decided how many groups he needed. But there's a shortcut to that. And it's simply this. He took the GCF and wrote it outside. And then he wrote all of his quotients, which is the answer in a division question. He wrote all of them. How many quotients would he need to write? How many quotients did he do here? 2. What if there were 3 things? How many quotients would he need? 3. What if there were 4 things? 4. And so on, and so on, and so on. Everybody cool? Now we're going to turn the page. You guys are not going to do the algebra tiles one, but you're going to watch me do it. What's the only way I can split these up the same? I got to cut them in half, don't I? And what do I have in this group? 2x squareds. And what do I have in this group? 3x. It'll show up. It's frozen. Right? And how many groups of both of those did I need? 2. Right? Everybody cool with that? Yeah?
Okay.
No, I don't want you to draw this.
Do you want us to No,
Nothing.
Sorry.
Everybody cool with that? Okay, now, what do you notice there and there? I only want you noticing this. There's still an x in both of them, yes? Because x is just a number, right? If x was a number, we would divide it out, correct? Right? So what do I do here when x is a letter? I just divide it out. Where does it go? Out to the front. What happens to these 2 x's if I take out one of them? I get 1 left. Do I write x to the 1? No. What happens to this x? He's gone. And what happens there? I put an x. That's doing this with a picture, yes? Now, let's do what Sam discovered 2 seconds ago and what we did on the other side of the page. Now I want you to write. I started out, and I'm going to change color to make it easier for everybody. I started out with 4x squared plus 6x, right? All of you look at that and you see, 4 and 6. I know that they will both take a 2, right? So, okay, I got to divide by 2. Awesome. X and x. They both have an x. How many x's are in both of them? One of them. So there is the first thing I did on the last page, right? There is my GCF. And I've divided everything by it. Now, what do? I write it out in this form. GCF bracket quotient 1 plus or minus quotient 2, and I just go on till I've covered them all. So what was my GCF? 2x. What was my first quotient? What's 4 divided by 2? 2. What's x squared divided by x? X. Right? Then it's a plus. So what do I write down here? Plus, what do I write here? Plus, what's 6 and 2? 3. X divided by x? Nothing. It's 1. 3 times 1 is 3, so we don't write the 1, correct? Bracket. And I'm done. Now, just to prove we're right, what is 2 times 2? 4. X times x, x squared. 2 times 3, 6. X times 1, x. Does everybody see? We are going to skip this one for now. We're going to come back to it later. Please turn the page over onto page 127. This is the first form of factoring polynomials that we are going to use. Now, guys, you know how I like to give you real-life examples of math?
Yes.
I have never found a real-life need for this, except to make math that does explain real life easier to do. Do you understand what I'm saying?
So it's like a support.
Yeah, this simplifies complicated math that we use to explain life. Okay? So, we're going to start with GCF. It's the first kind. So, we remember, the first step is to decide on a GCF. What do I have to take into account when I'm deciding on my GCF? Do I have to consider the numbers? Do I have to consider the variables? Do I have to consider the exponents? Yeah. So we decide on a GCF, and we have to think about numbers, variables, and exponents. Once we have that GCF, what was step 2? We've just done it twice. What did we do with that GCF? We divided what? Right. Step 2, when my pen starts working again. Step 2, we divided the entire polynomial. I wrote polynomial. The entire polynomial by the GCF. And step 3, how did we write our answer? It was, what did we write? The GCF bracket quotient 1 plus or minus quotient 2, and we just carried on until we were done. Is everybody cool? Everyone's cool? It's going to be there. It's being recorded. I just needed to look down, and I wanted to see how much I could get on the page now. All right, now, we're going to start with the easiest one we could possibly do. 5x plus 5. What's the GCF? 5. So I've decided on my GCF, yes? Step 1 is out of the way. GCF equals 5. Step 2, divide everything by the GCF. Divide by 5, divide by 5. Step 2, taken care of. Step 3, write the answer. What is the GCF? 5. What's the first quotient? X plus, what's the second quotient? 1. And I'm done. Got it? Okay. In the second one, what's my GCF? So what do I do with that? Divide everything by 3. What's my quotient? Or what's my GCF? Sorry. 3. What's my first quotient? 2x. Plus, what's my second quotient? 1. And I'm done. Now, what has happened in the third one? I got 3 terms now, yes? So I got to think of 3 that have a common factor. What is it? Our GCF is 3 again. But I've got some letters. There's an X, there's an X. Why do I have no letter in my GCF? Because 6 doesn't have an X. So I divide everything by 3. How do I write my answer? What do I write first? 3. Then all my quotients. What's the first one? X squared. Plus, what's the second one? 4x. Minus, so what's this one? Negative 2. And I'm done. Pretty easy, right? What's the last one? What's my GCF? 2x, because now there's an x in both of them. So what do I divide by? So what do I write at the front of my answer? 2x. What do I write in the brackets? 2x plus 3. And I'm done. Now, all of you should notice I left a giant white space over here, didn't I? Why? We're going to do a fifth one, and I'm not going to help you. Or 1, 2, 3, 4, 5. A fifth one. 18 AB squared minus 27 A squared B squared plus 36 A B C. Holy, Mr. Myers, on a Friday you do this to us? Does it look different? Do the rules change? Of course not. Because just like if I showed up here dressed like a 1960s teenage cartoon icon, dressed as he would look when he was 50, you still listened to me and did math. So what is... You guys take a moment. Figure it out. Talk to your neighbor if you need to. All right. What is at least one part of your GCF? 9. Because every one of those numbers divides by 9. Are there any letters that are common? How many A's? That guy's got 1 A. That guy's got 2 A's. That guy's got 1 A. No. What? Look at the example. 2x is 1x, so I could only use 1x. So up here, 1A, 2 A's, 1 A. I can only get 1 A. What about B's? 1B. What about C? None. So if that's my GCF, what do I do with every term? Divide by 9AB. 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 What goes outside the brackets? 9AB. What goes inside the brackets? 2. AA cancel. B squared divided by B? B. Minus. 3. AB. Plus. 4. A cancels. B cancels. C. All right. Now, listen, please, guys. Listen, please. Please, please, please. In some way that you will recognize how important this is. So I'm going to use a giant marker. Always try this. From now, November 3rd grade of your grade 10 year, until the end of your mathematics career, if you ever see a polynomial that you can GCF, what are you going to do? You're going to GCF it. The very first thing you try. Always try this. Okay? Now, let's do these 3. Let's do these 4, and then I'm going to leave you with like 8 questions for homework. And you got a whole weekend to do it. What is my GCF here? 5's the number. There's an X in everything. Any Y's? Nope. So what do I divide everything by? 5x, 5x, 5x. And what do I get out front?
5x.
And what do I get in the middle? 5 y plus 3x minus 6x y squared. Nicely done. What's my GCF here? So I divide everything by what? 2. And what do I get? 2, 4, plus 5a. Now, everybody please put a star here. Because something weird happens here. And you know how I say if it always happens in math, you're always supposed to do it? Okay. So what's our GCF? What does GCF stand for? Greatest common factor, yes? So what is our greatest common factor here? Negative is greatest? Damn! Negative's greatest? That's why there's a star here. If you can remove negatives by factoring -1 out. So looking at this, you see that negative at the very beginning, and you see they're all negative? We want to get rid of that negative. So the first thing we do is we would take that negative out. All right? So we are allowed, in this case only, when they're all negative, our GCF is going to be -5 CD. Nothing else changes. C, no, because there's only one C and one D. Everybody cool? That's what the star is. So now, does anything else change? No. So what do we divide this by? Negative 5 CD. What do we divide this by? CD. What do we divide this by? So what's on the outside? Negative 5 CD. What's this first one? Here's where it's going to mess you up. 4C cubed. Positive. Because there's two negatives there. What about this one?
Positive 6C squared D.
That was a powerful one, Sam. Plus 6, what? C squared D plus 5. Everybody cool? And then the last thing I want to show you is this. What's the GCF of 3 and 2? There isn't one. It's 1. Are any of the letters the same? No. So this one doesn't factor. Don't try to make something factor that doesn't. Everybody cool? All right, your homework, and I'm giving you all weekend to do it, plus the next 15 minutes is to do 1, 2, 3, 4, 5, 6, 7, 8, 9 questions. And you don't even have to draw a picture if you don't want to. You could just factor it. That's how much I care. Okay? Now, if you're smart, you'll get this done today, right now, because you got yourself a quiz on Monday. Just 128. That's it. I love how you say that. Just 128? Like you're going to do it. Okay. Yes, just page 128. And the last homework assignment was just 122, 123, and 124, and I gave you 4 days to do it. Oh.
Mr. Myers,
Carlos.
I wanted to ask you. I want to ask you something. I got the part where we had to find the greatest common factor, but I just didn't understand the part where we decide which letters we're going to be using.
Okay. It's the same thing.
For example, do it with this.
Yep. So, this guy has 4 C's there, right? This guy has 3. This guy only has 1. So the most that I can take out is 1 C. Because this guy can give 1 C to the front only. This guy can give 3. This guy can give 4. But this guy can only give 1. Same with D. So I have to choose the smallest exponent.
Oh, okay.
Okay? Because that's how many D's are there. This is really 20 C, 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 D, right?
Yeah.
And this is really C, 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 D, D, right? And this guy is just C and D. This guy can only send 1 to the front and 1 to the front. This guy can send 1, 1. This guy can send 1 and 1. So that's gone. That's C and D are gone. And that's gone. Leaving you with CCC, CCD, CCD, and nothing.
And what about this one? Why don't we have a Y there?
Because there's no Y there. This guy has no Y's to give at all.
Okay.
So we can only give X's.
Okay.
Got it?
Yeah.
Sweet. Yep.